Hello, my name is Andreas Zegowitz from the Fraunhofer Institute for Building Physics in Stuttgart, Germany. Welcome to the first video of the Module 2, where we are looking at the lighthouse project at RAJKOT. This module introduces you to the construction method monolithic concrete construction system from a building physics point of view. It includes 6 videos. As in the other modules, those videos address different construction challenges related to building physics in the context of the special climatic conditions in RAJKOT. They will cover the heat and moisture transport mechanism, the energy efficiency, the durability, and the thermal comfort. In the last video, the research overview wraps up the topic of this module. In this first unit, we will have a look at the construction in RAJKOT. We will have an overview of the construction system, look at how the construction is built up, what kind of materials are used, and what the building physics challenges could look like. In the end of this video, I will give you a brief preview of what to expect in the other videos contained in this module. This is a glimpse on the lighthouse project in RAJKOT, which is almost finished but not completely done right now. The projects contain a total of 1,144 housing units, and it is built as a monolithic concrete construction. Let's have a look. Let's start first with a description of the construction method itself. The lighthouse project in RAJKOT uses a monolithic concrete construction system. The special feature of this construction method is the use of a so-called tunnel formwork. This formwork consists of 2 L-shaped elements that are joined together to form a tunnel. The tunnel allows the wall and the slab to be cast simultaneously. This prevents the necessity of joints in the construction already during the casting process. The final result is a monolithic concrete construction. And this construction is very stiff due to the lack of joints and is therefore well protected against environmental influences such as earthquakes. The formwork is created and assembled in advance, so the final assembly of formwork elements has to be done on the construction site. The construction time is accordingly fast. The concrete used for casting is mixed on the construction site itself, taking care to use a mixture that meets the special conditions in RAJKOT, both in terms of load-bearing capacity, processing time, and so on. We will see in the course of the module what kind of effects the concrete composition ultimately has on the physical properties of the structure. For example, when it comes to improving the energy efficiency or evaluating durability and comfort. The non-load-bearing infills of the construction are filled with bricks. In this case, aerated concrete blocks are used. In principle, standard bricks can also be used. AAC blocks consist of lime, cement, fly ash and gypsum with a binder and foaming agent used to aerate the mixture. As a result, the bricks have a very low thermal conductivity. Moreover, they are lightweight but still have the needed strength. But what does the construction process itself look like? How was and is the lighthouse project in RAJKOT built? The construction can essentially be divided into two structural elements, the substructure and the superstructure. The substructure refers primarily to the foundation, which is built in the conventional way. First, the excavation pit is being excavated and leveled, then the reinforced is inserted, and finally the foundation is poured. This video shows the creation of the tunnel formwork made out of steel at a nearby factory. When the process of the ordinary foundation is done, the next step of the procedure, the superstructure, is built. As you can see here, this process begins with setup of the tunnel formwork, as already described. The ready-made L-shaped half shells are assembled on site and reinforcement steel is inserted. The formwork is then filled with concrete. Once the concrete has dried, the formwork element can be pulled out from the front or the back, usually after 2 or 3 days, depending on the mixture of concrete or the weather conditions. In this way, the complete building is created apartment by apartment, floor by floor, and in the end, a monolithic, load-bearing structure is the result. The open walls are then filled with the already described AAC bricks so that the apartment's raw building shell is finished. And now, after the construction process, this lighthouse project is almost finished, and this is what your lighthouse project in RAJKOT looks like from the outside. And here you can see the floor plan of an example flat in RAJKOT to imagine how it will look like from the inside, because it's not completely finished yet. Finally, I would like to elaborate a bit on the building physics challenges that arise with the construction method in this location. In depth, this will be covered in the next units of the RAJKOT module. The construction challenges that exist in RAJKOT are manifold, whether it is the choice of materials and their physical properties, whether it is the construction method, whether it is the climate conditions in RAJKOT. They all have an impact on the heat and moisture transport, on energy efficiency, on durability, or on comfort conditions in the apartments. And these are exactly the issues we are going to deal with in the following units of this module. First of all, the second video will be about heat and moisture transport. In this video, we will take a deeper look at the radiation to the surface of the building components. What happens with this radiation? What effect does it have on the surface temperature inside and outside? Since we have quite high heat capacities in this building, we will also discuss the concept of a temperature adjustment. You will see what this is and what impact it has. In the third unit, we'll take a deeper look at improving energy efficiency in this type of construction. We'll look at different energy balances and look at what steps can be taken towards an energy efficient building. For example, we will see what impact insulation or even the use of white paint has on energy efficiency. Then, in the fourth video, we'll look at algae growth and corrosion, and where they can appear on the structure. The algae growth, for example, on the exterior surface of or the corrosion within the concrete itself. In the 5th video, we are going to take a closer look at the comfort conditions and how they are evaluated. We are going to look at temperature smoothing and body's response to those temperatures and what we can do to improve the comfort of the people who live or work in the space. Then, in the last video, we present research on a technology that will allow us to recycle concrete in the future. Going through this module, you will have a comprehensive overview of these aspects within the RAJKOT project. And by taking a deeper look into what is happening here and why it is happening, you will gain knowledge on how to manage and improve the building physics challenges in other projects as well.